Dear students, in this class we are going to be discussing about the electrophilic substitution reactions in the phenols. In this phenol, if you are going to be taken the phenol, that is benzene ring, which is directly attached to the OH group. That is OH group in the phenol, OH group in the phenol, which is going to be activates the benzene ring, which is going to be activates the benzene ring towards the electrophilic substitution reaction. This OH present in the phenol, which is going to be, that is directs that is the incoming group to the ortho and the para position. These phenols which undergoes the electrophilic substitution reactions at the ortho and the para positions. We will discuss some of the electrophilic substitution reactions in this class. The first we are going to discussing about the nitration. That is first we are going to be discussing about the nitration. In the nitration, first we are going to be discussing either by treating the dilute nitric acid, either by treating the concentrated nitric acid. First we will discuss about the, that is with dilute HNO3 nitric acid. That is the phenols is treated with the dilute nitric acid. Dilute nitric acid at 20 degrees Celsius. At 20 degrees Celsius, it's going to be used the para-nitrophenol and ortho-nitrophenol. We are going to be get the products, that is the phenol. The phenol is going to be treated with, the phenol is going to be treated with the dilute nitric acid at the 20 degrees Celsius. 20 degrees Celsius. The products we are going to be obtained is, that is ortho-nitrophenol, that is ortho-nitrophenol plus para-nitrophenol, plus 2H2. Then we can get the 2 molecules of phenol. This about the with the dilute nitric acid means the upcoming group means, that is nitro group, which is at the ortho and the para positions. This is going to be the OH group present in the phenol, which is going to be directs the incoming group to the ortho and the para positions. This about the with the that is dilute nitric acid. This ortho-nitrophenol and para-nitrophenol we can be separated by the steam distillation. If this ortho-nitrophenol is there, this is going to be steam volatile. Is that steam volatile? But para-nitrophenol is there, this is going to be less volatile. Due to that, in this ortho-nitrophenol, intramolecular hydrogen bonding we will see. The intramolecular hydrogen bonding. But in the para-nitrophenol, intermolecular, that is intermolecular hydrogen bonding. Due to this reason, that is para-nitrophenol is less volatile, but ortho-nitrophenol is more volatile. This is volatile with the steam volatile. How we are going to be intermolecular means, that is if you are going to be taken that ortho-nitrophenol, that is NO2, then OH, then is going to be form the bond with this. That is between the bond is going to be formed between the oxygen and the nitrogen. nitrogen. This bond is going to be formed between the oxygen and the oxygen and the hydrogen. This we call it as a intramolecular hydrogen bond. Intramolecular hydrogen bond. This we call as a intramolecular hydrogen bond. In the para-nitrophenols, we are going to be see that is if you are going to be taken that is NO2 group. Then if you are going to take the OH, that is in this, there is another molecule is going to be present, that is nitrogen, double bond O, then O. It is going to be from the hydrogen bond. Means the hydrogen of the one molecule and the oxygen of the another molecule. This we call as a intermolecular hydrogen. This is about the in the para-nitrophenol. We can find that intermolecular hydrogen bond. In the ortho-nitrophenol, we will find the intramolecular hydrogen bond. Due to this specific character, we can be these two products we can be separated. That is ortho-nitrophenol and the para-nitrophenol we can be separated by using the steam distillation. Like this only we will discuss about this how it reacts with the concentrated nitric acid. That is nitration with the concentrated HNO3. That is phenol is going to be treated with the mixture of concentrated HNO3 and concentrated sulfuric acid. We are going to be get that 2,4,6 trinitrophenol we are going to be get. This commonly called as a picric acid. There is phenol. Phenol is going to be treated with the mixture of concentrated HNO3, that is concentrated nitric acid, and the concentrated H2SO4. The product we are going to be obtained is 2,4,6 trinitrophenol. That is 2,4,2, second position. Then fourth position, that is NO2. Then sixth position. The name of this compound is 2,4,6 trinitrophenol. This commonly we call it as a picric acid. This we call as a picric acid. Plus that is 3H2. That is going to be treated with the concentrated HNO3. It's going to be treated with the concentrated HNO3. We are going to be get that picric acid. We are going to be get that picric acid. This is also an important reaction as in the examination. How the nitration with the concentrated HNO3. The phenol is going to be undergoes nitration with the concentrated HNO3. It is going to be used as the product we are going to obtain is 2,4,6 trinitrophenol. This also be called as a picric acid. Next, we are going to be discussing about the next is another electrophilic substitution reaction, that is bromination. Now we are going to be discussing about the bromination with bromine water. That is the Br2H2. That is bromination with the bromine water. Means when the phenol is going to be treated with the bromine, that is the bromine water, we are going to be get that is the white precipitate of 2,4,6 tribromophenol. We are going to be get that is when the phenol is going to be treated with. Phenol is going to be treated with the bromine. Is going to be treated with the bromine water. That is the bromine water. We are going to be get that 2, that is 2, 4, 6 that is 2 comma 4 comma 6, that is tribromophenol. The white precipitate of 2 comma 4 comma 6 tribromophenol. Tribromophenol we are going to be get that. This about the with the bromination with the bromine water. And like that only, if you are going to be bromination with bromine in the presence of carbon disulfide. In the presence of carbon disulfide. That is when phenol is going to be treated with the, that is a bromine in the presence of, that is carbon disulfide. Carbon disulfide, we are going to be get the product orthobromophenol and the parabromophenol. That is the phenol is going to be treated with the, that is bromine, treated with the bromine in the presence of CS2, that is carbon disulfide, at 0 degree Celsius. At 0 degree Celsius, the products we are going to be obtained is, the product we are going to be obtained is, that is the products we are going to be obtained is orthobromophenol plus parabromophenol. Plus 2HBr. Then take that. There is 2HBr. There is the phenol is going to be treated with. The phenol is going to be treated with the bromine in the presence of carbon disulfide at 0 degree Celsius. We are going to be given that orthobromophenol and parabromophenol. This is about the bromination. This is about the bromination with bromination with the bromine in the presence of water. We are going to be get that 2 comma 4 comma 6 tribromophenol. In the bromination with the bromine in the presence of, that is carbon disulfide, we are going to get that orthobromophenol and parabromophenol we are going to be get that. Next we are going to be discussing about the another important reaction is pole-based reaction. And this the phenol pole-based reaction, the phenol is going to be treated with the sodium hydroxide. We are going to be get that sodium phenate. This sodium phenate on heating with the carbon dioxide at 140 degree Celsius under the 6 to 7 atmospheric pressure. At that time, we are going to be get the sodium salicylate. This sodium salicylate on acidification is going to be use the, that is the salicylic acid. The otherwise called as a 2-hydroxy-benzoic acid. So salicylic acid also called as a 2-hydroxy-benzoic acid. In this acid, the pole-based reaction is very important for the examination purpose. So many times asked in the examination. In this, the phenol is going to be treated with the sodium hydroxide. Is going to be treated with the sodium hydroxide. That is NaOH. And the sodium phenate is going to be obtained. That is, we are going to be getting that sodium phenate. ON. That is the name of this compound is sodium phenate. Sodium phenate. This on heating with the carbon dioxide. This on heating with the carbon dioxide under the pressure is 6 to 7 atmospheric pressure and at 140 degree Celsius. At 140 degree Celsius, at that time we are going to be get that sodium salicylate. We are going to be get that sodium salicylate. It is COON. We are going to get that the compound is sodium salicylate. This on further acidification. The sodium sulfate for the acidification, we are going to be get that the salicylic acid. We are going to be get that the product we are going to go obtain is that is salicylic acid. That is COH. The name of this compound is salicylic acid. Then the otherwise we call it as a 2-hydroxy benzoic acid. 2-hydroxy benzoic acid. This reaction we call it as a cold base reaction. Directly you can start from here also, no problem. In the cold base reaction, directly you can start. That is sodium phenate is going to be heated with the carbon dioxide at 140 degrees Celsius under the pressure 6 to 7 atmospheric pressure. At that time we are going to be get that sodium salicylate. This sodium salicylate further acidification we are going to be get that is salicylic acid. This reaction we called as a that is the cold base reaction. This reaction we called as a cold base reaction.